All right, so diving right in. So the sister module to the widget.ts module is the layout module. And so this, I believe, is the only circular reference, the two modules that have circular references to each other in Phosphor, because they both depend on the type definitions of each other. So, and when I say circular reference here, I really just mean to the type definitions. There's no actual, I don't believe there's any runtime code that is circularly dependent. So the imports, I believe, in this case for widget are just for the typing definitions. So there shouldn't actually be any runtime circular dependencies, just compile time circular dependencies. And okay, so the layout class is an abstract base class. And by abstract base class, I literally mean it's using this. I think this is the first time we've seen in Phosphor the TypeScript abstract class notion construct used. And basically what that means is that you can't directly instantiate an abstract class. So an abstract class can have abstract properties and abstract methods and sorts of things, other abstract constructs that you must implement in a subclass in order for the necessary behavior for you basically to have a complete layout class. So the layout class by itself cannot be instantiated. The compiler won't allow you to do it. And so this is kind of handy because it forces you to subclass and it forces you to implement a certain abstract interface. Now, the first question is why use an abstract class over an interface? And the answer is that there's a lot of default functionality that you get with the base layout class, and that's very convenient. That is pretty much common to all layout implementations that the user will write, whether it's the user here being the actual Phosphor package or anybody implementing custom layouts. And so it makes more sense in this case to have a base class that provides all of that functionality and then have abstract methods for the behavior that needs to be filled in. And so, so that's what we've done here. And so basically going right into it. So the first thing you're going to do is construct your layout, or when you construct an instance of a layout, and the base class takes an options object, the same sort of options object pattern we use everywhere else in Phosphor. And there's one option for the base layout class. So let me go ahead and scroll down to that documentation and definition, which is right here. And so what we have is a fit policy for the layout. And basically what this is it's a bit of a steal from Qt's, what they call the size policy concept from Qt. And basically what we're saying is when a parent widget is fit, so when a parent widget that has a layout is processing a fit request message, what should it do with the size constraints that it computes, that the layout computes? And by size constraints, I mean the bounds, the size limits that are computed for the parent widget, notably the minimum size that's required to lay out all of its children and the maximum size that it's allowed to occupy based on the maximum sizes of all of its children. So as an example of this, if you've got a horizontal box layout, the minimum size of the minimum width of that horizontal box layout is going to be the sum of all the minimum widths of the children plus whatever spacing you have between the children. Correspondingly, the minimum height of a box layout is going to be the maximum of the minimum heights of all of the children. So it's not a sum because it's horizontal layout. And so you can have similar logic for computing the maximum size. Lots of times there will be no maximum size because maybe one of the child widgets doesn't have a maximum size. So in that case, you have a child widget that can expand infinitely in width and height. And so the layout itself won't have a maximum size. So what the fit policy does is it determines what the layout does with that computed information. And if we look right above this options object, we have this type alias that's defined here. And it says it's a type alias for the layout fit policy. And the fit policy controls the computed size constraints, which are applied to the parent widget by the layout. And some layout implementations may ignore the fit policy. I believe all of them that are defined in Phosphor obey the fit policy. You may have some of your own that do not obey the fit policy, in which case it could just be ignored. We have two defined at the moment. The first is you set no constraint, which means that the computed minimum and maximum sizes for the parent widget are ignored and they're not set at all. The second one is the computed minimum size will be applied to the parent widget. This means that the layout is actually going to go and write the CSS property for the parent widget to set the physical minimum size of that widget in pixels. And so this will have an effect on how the browser actually renders the widget, so you don't have any overlap or overdraw or any of that sort of thing. What we did have at one point was set minimum and maximum size and simply set the max size, which are things that exist inside of Qt. But I believe that we had a long discussion about this and determined that those aren't needed because it's a very foreign concept in a web application for something to have a maximum size, and it basically leads to some situations, particularly in the dock panel, which can be non-intuitive. So somebody will, set a maximum size on a child widget and then not understand why some other parent widget that's holding a box layout with that child is now not expanding to fill the available space in a dock panel. So setting maximum sizes on things can sometimes have confusing emergent behaviors that we decided to just avoid by always ignoring the maximum sizes. And so what that allowed us to do by saying we just ignore the maximum size is, I believe we, in lots of places, we just no longer compute it because we don't care about it. And so it actually saves some time in the layout as well because we are computing minimum sizes. Should we decide that that was a mistake in simplifying things, we can come back and we can update the fit policy and update the layouts to handle the maximum sizes. We'll just have to figure out a way to message that to users. And since it would be changing this type alias, it would be a breaking change, so that would have to be Phosphor 2.0. Moving on.
Could you just, I don't think I quite understand the fit policy. Could you give an example where you use, or like why would you use one versus another?
So let's say that you, for some reason that you've got some layout and, you've got some children that have some weird minimum size and you actually don't care about obeying their minimum sizes. So you don't mind if the parent widget clips the content of the children because it's really big, or you're doing your own custom scrolling or something like that in CSS, or you've got some weird situation where you simply don't want this particular layout to set the minimum size of the parent widget based on the computed minimum sizes of the children. In that case, you don't have to implement your own brand new box layout. You can just change the fit policy, have the box layout ignore those computed minimum sizes, and then the parent widget will be able to shrink to 0. Or alternatively, you know better what the minimum size of the parent should be, and you want to manually set that yourself in CSS, and you don't want the layout to do it. And so in that case, you could set the size policy again to ignore the size constraints, and then you'd be responsible for setting the minimum sizes yourself as the user.
Okay, so ignore the size constraints gives you more control kind of over the minimum size of your
Yes. So basically, you don't like what the layout is doing by how it computes the minimum size. You can turn that off and set it yourself.
Cool. Thanks.
Still have all the behavior. Otherwise, still have all the behavior of the layout. Okay, moving on. Got the dispose method. This is pretty typical. Sets the internal. It nulls out the internal state, clears all the signal data, and clears all the attached property data. The layout is not a message handler, so it doesn't have to worry about any attached messaging data. So that's why you don't see that in, you don't see message loop.clear data in this destructor because it's not part of the message loop at all. What you do see is that we're not checking the is disposed flag and then doing nothing. That's because you can call this method multiple times and the result will be the same. So once you call this the first time, setting the parent to null again and setting dispose to true again, or clearing all the data, that's basically a no op. So you don't have to. I don't do the check here just to keep the code clean. We've got the flag to test whether the object is disposed, implementing that iDisposable interface. Have a getter and a setter for getting and setting the parent widget. Typically, you're only going to care about seeing what parent widget owns the layout. And this is a bit of a misnomer. We're calling it parent, but a layout is not actually a tree. But in this case, the parent is going to be the widget which owns the layout, and the layout is responsible for laying out the children of that widget, and so that's why we're calling it the parent. So in the concept of a hierarchy of a parent widget and children widget, child widgets, the layout is laying out the children for this particular parent. So that's why we called it the parent over just plain old widget or anything like that. Then you have the setter to set the parent, and then the notes here. This is set automatically when the layout is installed in the parent widget. The parent widget should not be set directly by user code. And this is true always. If we recall, the setter for the layout on the widget, when you set the layout on the widget, that setter is responsible for setting this parent value. So if you do it in the opposite order, if you try to set the parent first, it's not going to work how you intend. So you should always set the layout on the parent and not the parent widget for the layout. So you basically just, as a user, ignore that the setter exists. It runs through some checks to make sure that you're not changing the layout or you're not installing it again, and basically you're only using it once, running through some logic for that. Then it's assigning the internal parent widget, and then it calls init. And I believe this is the first abstract method that we have on here. Maybe not the first, but nope, it's just it's not abstract. So we'll get down to it then. But basically what you have is an option to have two-phase initialization on a layout. Because what that means, when you create a layout, you're going to initialize it with some stuff. Maybe you're going to add some widgets to it and that sort of thing, but you don't necessarily want to compute any size, or you can't compute any initial sizes for one reason or another until you actually have a parent widget, because maybe the layout needs some information from that parent widget. And so you can construct your layout, add a bunch of widgets to it, and then once the layout is actually added to the parent widget, this init method is called, and that allows you as a layout author to do whatever's necessary to initialize your layout now that it's been added to the parent widget. Then we've got some getters and setters for the fit policy. If you change the policy, we basically clear the size constraints for the widget, because obviously you're changing the fit policy, and so we need to recompute everything. So we clear the values of the computed styles and then request a new fit of the parent. So again, if we recall what the fit method does for the parent widget, it will post a fit request message to the widget itself. And we'll see later in this file how that comes back to us for processing. Which reminds me, let me go ahead and open the widget file for view in just a second here, because we'll need that. Okay. So, all right, so now we get into the abstract methods that must be implemented by a subclass, of which there are two. So the first one is the iter method. If we look up at the top of the layout class implements the iterable interface, and we talked about this before, whether we're going to keep this for 2.0 or whether we're going to go and use move to ES6 iterables. But in any case, this iterable interface will probably remain, and what the iter method will do is, instead of returning an I iterator, it's going to return an ES6 iterator. And that's probably the only change we're going to make for 2.0. But in this case, it's part of the abstract interface. So any subclass of layout must implement the iter method and return an iterator of widgets. And so this right here is what allows you to basically iterate through the hierarchy of Phosphor widgets, because the only way you can add children to the only way you should add children to a widget is through a layout. And because layouts are iterable, we can now start constructing iterators that move through the tree or navigate through the tree of widgets without actually having to care how any particular layout stores its widgets internally. For example, the box layouts and things that do linear sort of layouts might simply store their child widgets in an internal array, which is fine. And then, making an iterator over an array is fine. We have that built into the Phosphor algorithms package. However, for something like the doc panel, which actually stores its child widgets as an internal tree of stuff, it's a little bit more difficult. So you can't just simply iterate over an array of that. You have to write a little bit more of a complex iterator, but it's still possible. And so what that allows us to do by simplifying everything into this iterator interface is that for the code that's going to be walking the tree of widgets, it doesn't care how a particular layout's storing the widgets internally, whether it's a tree, whether it's in a flat array, it doesn't matter. Ultimately, it's all represented as a flat iterator. And so that makes it convenient and uniform to navigate the tree of widgets. So a subclass must implement that. And the only other thing it must do is implement the remove widget method. And remove a widget from the layout. If we read the notes, a widget is automatically removed from the layout when its parent is set to null. So this method should only be invoked directly when removing a widget from a layout which has yet to be installed on a parent widget. And this method should not modify the widget's parent. So the reason this exists is for what's described in the notes, where this method should only be invoked directly when removing a widget from a layout which is yet to be installed on a parent widget. So if this method didn't exist, for example, let's just take an example. Let's say this method didn't exist and you create a box layout and then you add a bunch of widgets to it. And then you decide to say, oh, actually, I don't want this child in this layout. I want it in another layout. Well, if the only way to remove a widget from the hierarchy is to set its parent to null, how do you get that child widget out of the layout if it hasn't yet been added to, if that layout hasn't yet been installed on a parent widget? If it hasn't been installed on the parent widget, all of the child widget's parents are null. So it's technically not in the hierarchy yet. So how do you get it out of the layout? And the answer to that is you would call remove widget. So that's why this method exists. Because in that one-off side weird edge case where you might need to remove something from a layout and the layout hasn't yet been installed on a parent widget, we have to have a way to do that. So that's what this method is for. Conveniently, since we require this method, we can also leverage it as part of the base class logic so basically when we detect that one of the children that we're managing when their parent has been set to null, the layout base class will automatically call this method, and that allows any subclasses to remove that widget from their internal state as necessary. And we'll see that in just a minute here. All right, so moving on, we have this method called process parent message. Now this looks very similar to process message that you would have as part of the message handler interface. But as I mentioned before, the layout object is not a message handler purely for performance reasons. So the parent widget is already receiving messages as necessary. And if we recall back in its message handler method, the process message, it's calling this notify layout method for every single message that it gets. And if we look at that, notify layout, that's if we have a layout, we go ahead and call this process parent method on the layout to give the layout an opportunity to handle the message. And that's this method right here. So the base layout class is doing a lot of message processing for us. It's going to handle, resizes, update requests, fit requests, basically all of the stuff that might be relevant for a layout to react to is handled by this base class, and then again, basically farmed out to one of these convenience protected methods. Sometimes they're doing things, sometimes they're not, but we'll go through each one at a time. But ultimately, what's happening here is that this base class is handling this, has written this giant switch case statement for us and broken out all those message types into specially named methods that are protected that you can re-implement in your subclass if you need to. One of the benefits of that is that if it recognizes a certain message type and it realizes that that message is a certain type, it will go ahead and do that casting for you, so you don't have to do that casting in your own overridden methods. It's already been done for you. So this switch case statement's pretty straightforward. There's nothing special going on in it. It's basically just translating from string name to method name. All right, moving on. So that's the public interface of the layout. So we've got a couple of abstract methods that must be implemented by a subclass. And we've got a few, we've got this one process parent message, and then we move on to the protected interface. So some of these, many of these, I should say, these methods will be re-implemented in subclasses depending on what the subclass layout is going to do. So the first one is the initialization method. So perform layout initialization, which requires the parent widget. So again, this is phase 2 of layout initialization. The method is invoked immediately after the layout is installed on the parent widget, and the default implementation reparents all the widgets to the layout parent widget. So if you were wondering how after you add all of your child widgets to a box layout, and then you set that layout on your parent widget. If you were wondering how all of those child widgets got reparented to that parent widget, this is the answer. This is that line of code right there that does that. So whenever your box layout or your panel layout or your split layout or your dock panel layout, whatever layout it is, once you've initialized that layout, as soon as you install it onto the parent widget, once this base class init method gets called, this is where the reparenting is actually done. So what we're doing is we're iterating over the layout. And if you remember, so if we call each, this is a method in Phosphor algorithm, which is like a for each, but for iterators. So that abstract iter method is going to be called as a result of this to get the iterator of child widgets. So for every child widget in this layout, we set that child widget's parent to this parent widget. So it should be pretty straightforward. Most layouts are going to re-implement this, and before those layouts perform any logic in their own init method, they're going to call super init, which will eventually cause all of the child widgets to be reparented. All right, the next one is the message handler that's invoked on resize messages. And always important to read the notes. So the layout should ensure that its widgets are resized according to the specified layout space and that they are sent a resize message if appropriate. So this is what this right here, this on resize method, this is the magic that basically allows us to react to resize messages throughout the hierarchy in Phosphor and actually relay out all of the child widgets according to the new layout space. The default implementation of this method sends an unknown size resize message to all the child widgets, and this may be re-implemented by subclasses as needed. So the base layout class doesn't actually do any layout, contrary to its name. This is just scaffolding for you to implement your own layouts or for Phosphor to implement its own layouts. So what that means is that in the absence of any computation that's done on this in response to this resize message, the only thing that the base layout class can assume is that CSS is responsible for laying out all of the child widgets. And if that's the case, JavaScript and this base layout class has no knowledge of how those children were resized because it's arbitrary. It's not going to go through and try to compute what the resizes were by reading geometry from the DOM because that's super inefficient. It's also not going to try to parse the CSS and figure things out by re-implementing all those algorithms. It's simply going to punt and send a unknown size resize message to all of the child widgets, which is basically a resize message where the width and height are -1, and that's an indication to that child widget that says, hey, look, you may have been resized. I don't know what your current size is. Do what you will with that information. So that's what's going on here in the base class. Yes.
So that means that if you re-implement this method, you should not call super.
Correct. Yep, that's correct. And so that's what the first note says. The layout should ensure that all of its widgets are resized according to the specified layout space, and that they are sent a resize message if appropriate. And so if it's appropriate, you might call super at some point. If it's not appropriate, don't call super. So that's just, in this case, the default implementation, which you may want, not want. Most of the layouts, I believe, all of the layouts except the panel layout, because the panel layout is intended to be used with CSS styling. So all of the layouts except the panel layout on Phosphor re-implement on resize and do not call super. Don't quote me on that, but I think that's correct. Okay, moving on. So the message handler invoked on an update request message. And the notes here are the same as the notes for a resize, because for layouts, when we're talking about the context of an update request for a parent widget which has a layout, updating it should be the same operation as resizing it. Basically, hey, update basically the position and sizes of all of your children because something has changed in the application which requires that. And if you think about that logically, if you resize a parent widget that has children, you want all of those children to be relayed out. But at the same time, what does it mean to update a parent widget? Well, conceptually, it means exactly the same thing, relay out all of the children. So the logic for resize and for update requests, only in the context of a layout, should be identical. And we'll actually see in the implementations of the layouts that they actually do they do the same thing. So they'll call out to another private internal method which has the same logic for both resize and update, with some slight caveats. Basically, when you get an update request, it's impossible for you to know what the current sizes are. So typically, you're gonna basically do a resize or a relayout starting from an unknown size rather than starting from a possible resize message there where you do know the size. But we'll get into that when we get into some of the other layouts. But for the base class, the logic is exactly the same. Moving on, we get before attach and after attach messages. So this is how the before attach message and after attach messages start getting proxied from the top of the hierarchy down. So when a parent widget gets a before attach message, and that parent widget has a layout, because if you have children, you should probably have a layout because that's how the framework is designed, that layout is going to proxy the before attach message to all the child widgets. Now, that's recursive logic, right? Because the child widget itself might be a parent, and that child widget being a parent might have, a layout. And so this bit of logic right here is what causes that before attach message to be proxied all the way from the top of the hierarchy all the way down. And we know that since the before attach message is a singleton message, we don't need to create a new message. We can just forward that message directly onto the child widgets. Same logic applies to the after attach message. Same logic applies to the before detach message and the after detach message. So those 4 message handlers right there are responsible for proxying those messages all the way down the hierarchy. Again, it's one of those, this is by having a tree structure of widgets, this is one of those things that, the code is simple, but the emergent behavior is, can be quite complex to wrap your head around. Okay, now moving on. So we have the before show and the after show. These are also messages that should propagate down the widget hierarchy until you find a widget that is hidden. Because if a widget is explicitly hidden, it won't be shown even if one of its ancestors is being shown because it's been explicitly hidden. So the base class layout handles that logic for us. So it will propagate a before show message down the hierarchy until it encounters a child widget that is explicitly hidden. If it encounters a child widget that's explicitly hidden, it will not get that message, and the propagation will then stop with that, basically with that subtree or that branch of the hierarchy. Same logic applies to the after show messages. Same logic applies to the before hide and after hide messages. All right, then moving on, we have the handler for the child remove message. If we recall where that, from the widget class, where that message is actually generated, if we set the parent widget to null right here, so we've got a widget, we're setting its parent to null, and that widget has a parent and that parent is not disposed, this block right here sends a message to that parent widget called child removed through the message loop. And if we recall through the process message method of widget, the layout for that parent widget is going to get a chance to handle that message. And this is where it handles it right here. So it's going to handle that child remove message, and it's going to call that abstract method on this layout class called remove widget. So this gives you an opportunity as the author of a layout class, because you've got a subclass layout, to implement your remove widget method and actually physically remove this child widget from your internal state, whether that's an array, whether that's a tree hierarchy of stuff, however you're storing your child widgets. This gives you an opportunity to go ahead and remove it in response to that method. And typically, this is all that needs to happen. You should never actually have to re-implement this method. You should implement and do all that logic in remove widget, because that logic should be the same, whether it's called directly by the user because the layout hasn't been installed on a parent widget yet, or it's called as a result of processing the message because the child widget's parent has been set to null. So subclasses should not typically re-implement this method. But maybe you've got really some custom thing that I haven't anticipated and you need to. So that's why it's a protected method. So you shouldn't typically do it, but maybe you need to. So you can if you want. All right, the last 3 on layout: fit request, child shown, and child hidden. The default layout, there's no behavior that can be assumed to be valid for any of these messages by the base layout class. So the default handlers, the default implementations are no op. For most layouts, you're going to implement these to do something. Most layouts will basically consider the child size 0 if it's shown or hidden, so they need to react to that information. And they're probably going to need to do something on a fit request message, so they're going to need to be re-implemented. But the base layout class can't do anything, so they're just no ops. So you never have to call super on those. All right, a few minutes left, moving right along. So we talked about fit policy and the options already. Now we're going to talk about horizontal alignment and vertical alignment. This makes sense for certain widgets and certain layouts. So for example, both box layout and split layout will handle horizontal alignment and vertical alignment for child widgets. What this means is, let's say you've got a child widget where the maximum size of the child is, or let's just say the height, for example. The maximum height of one of your child widgets is smaller than the minimum height of one of its siblings. Well, minimum size, minimum height takes precedence. So that split panel is going to be at least tall enough to show all of the siblings without clipping. So it's going to be at least as tall as the smallest minimum size. But you have another child widget whose maximum size is smaller than that. So what that means is you've got empty vertical space that needs to be allocated somewhere around that child widget. How do you allocate that space? That's what this vertical alignment property tells us. It's basically saying, in that empty space, how do we want to vertically align this widget? Should there be any empty vertical space? Do we want that child widget aligned to the top of the empty space? Do we want it centered in the empty space? Or do we want it below all of the empty space? Same logic applies to vertical box or split layouts and horizontal width. So if you've got any empty space to the left, right, or center of any of those widgets, how does that need to be aligned? Since horizontal and vertical alignment can apply to multiple layouts, but it doesn't apply to every layout, and it really applies only to the widget itself that's going to be added to that layout, it's defined as an attached property on the layout class. So let's say that you're going to create some child widgets and you want to add them to a box layout, but you want to control the vertical alignment for one of those particular children. The way you would do that is with layout.getHorizontalAlignment or layout.setHorizontalAlignment on those particular child widgets. So, and then reading through the notes, the layout width allocated to a widget is larger than its maximum width. The horizontal alignment controls how the widget is placed within the extra horizontal space. So it's basically what I just described. Similarly, if the allocated width, so the width that's going to be set for that widget is less than the widget's max width, then the horizontal alignment has no effect. And some layout implementations may ignore horizontal alignment, which is true, for example, of the panel alignment. The panel alignment ignores all of this because it's saying you're using CSS for layout, so ignore all of this TypeScript logic. So this is just the getters and the setters for the horizontal and vertical alignment properties. And then we have a convenience class. I believe this is the last public thing in this module, which it is. And this is an object which assists in the absolute layout of widgets. So when I mean in the absolute layout of widgets, I mean the actual computing of the layout coordinates in pixels and the width and height of the widgets in pixels, and using the CSS position absolute in order to do the layout. So when we're talking in the context of like a panel layout where you as the user of Phosphor are styling things and laying out things with CSS, that is not an absolute layout. When you're using something like box panel or dock panel or split panel, where Phosphor itself is computing the X, Y, width and height positions of all of these widgets and assigning those values to the inline CSS style of the widget, that is an absolute layout. And this class is used to assist with some common computations for those particular widgets. So looking at the notes, this class is useful when implementing a layout which arranges its widgets using absolute positioning. And this class is used by nearly all of the built-in Phosphor layouts, which is true. And so rather than make this a separate file or a separate module, we've just thrown it in at the bottom of this layout.ts file. So you construct one, and the way that you do that, it basically wraps a child widget for you. And the first thing that it does, it sets the positioning, the inline style. So if we remember this .widget.node, that's the actual DOM node that represents the widget. Now you can do the style and set the inline CSS position value to absolute. Does that on startup. It's got a dispose method because it implements that disposable interface. And then what it does is it resets, when it's been disposed, it resets all of the inline style information that it may have changed for the widget back to basically back to null. In this case, I do check the disposed flag because writing to a CSS style can be expensive, and depending on the browser that you're running in, it may not detect that you're setting these values to the same values that they already were, and it might schedule a DOM reflow. It might not. It depends on the browser. So rather than risk it, we just check that Boolean flag and do nothing if we're disposed the second time. Got a public read-only attribute to see what widget this layout item is wrapping. And then we've got a bunch of convenience getters for getting the cached bin width, getting the cached bin height, cache max width, cache max height. Notice I'm using the value cached here because we don't want to be reading this value from CSS every time we need it for a couple of reasons. One, the first time you read it, it may or may not trigger a reflow depending on the browser that you're in. Number two, it's going to come back as a string, which needs to be parsed into a number to be useful in computations. That parsing is not free. And so we don't want to do that expensive operation every single time we want to get the minimum height of a widget. So what we do is basically wrap that widget in this layout item object. When we need those values to be updated, we can call the fit method on the layout item, which computes all that information, parses all of it, and caches it in internal state, and then gives us a read-only view into that computed information. So now we can refer to the layout item at any time we need this cache data, and we don't have to basically store it as local variables or parse it all over the place. It basically just encapsulates all of that parsing and caching for us in the same location. It's also got some convenience read-only getters that just proxy out some state for the widget. These is hidden, is visible, is attached. This is stuff that's used all the time by layouts, so they're just re-exposed here as a convenience. Then we've got the fit method, which updates the computed size limits of the managed widget. So here's that expensive call right here, which actually reads the size limits from the DOM and CSS and does all the parsing and gives that back. So we only do that once and then break out all that data into internal state. And is this the final method? Yep. So finally, we have the update method, which updates the position and size of the managed widget. So let's say I'm a layout. I've got a bunch of these layout items that are wrapping the child widgets that I care about. I've done a bunch of math, and I've decided where and how big this widget should be. So I've determined the XY width and height for the widget, or in this case, the left top width and height, to use CSS terminology. So once I have all of that, I need to apply that to the widget in a couple of fashions. I need to apply it to the absolute position in CSS, so the inline CSS style. And then I need to tell that widget that it's been resized. So preferably, if I know the previous size of the widget as well, I can tell the new widget how it's been resized. So I can give it like a DX and a DY, or a delta left or delta Y. I believe do we provide that? Nope, we just do the current size. So never mind, ignore that last part of what I said. So in any case, running through this, so the first thing that we need to do is ensure that the width and height that we've been told to lay out the child widget to does not exceed its computed minimum width or minimum size and maximum size. We've already computed that information, so it's very cheap for us to do this clamping operation. And the reason we do this is not because the browser will render things incorrectly. Like if you set like a minimum size of a DOM node in CSS, and then you try to resize it smaller than that, the minimum size will win. So visually, it would be correct. But what would happen is that the values that we would report to the widget in its resize message might be wrong. And if it's relying on those to be correct, then you could have some subtle logic bugs. So we go ahead and do this clamping operation as appropriately. And basically what the layout item also does is handle all of that horizontal alignment for us. So if you're using layout items and you don't have to worry about allocating, what am I trying to say? You don't have to worry about managing yourself the logic for computing what to do with that extra layout space, or how to manage the horizontal vertical alignments. The layout item does that for you. So it will detect if the width that you've allocated for this widget is greater than its maximum size. Then it's going to check to see whether it's got a, I'm getting tongue-tied here. It's going to check the proper horizontal alignment for that widget and then handle that for you. And I like to do in all of my switch case statements, have a default method, even if the only option is that it can never be reached. And so if somehow we have some really unrecoverable bug or some weird thing happens in the program, we'll get an exception. And so if you ever see something in Phosphor that throws an exception which just says unreachable, then you can be 100% absolutely sure it's a bug in Phosphor, and please report it, just as an aside. So, so the layout item adjusts the left edge for horizontal alignment and adjusts the top edge for vertical alignment. Then it sets up the resize variables. And okay, so we are caching the left top width and height internally to the layout item. And what that allows us to do is optimize the writes that we do to the CSS style. And again, this is done for two reasons. One, so we can detect if a child has been resized. And two, we're only making writes to the CSS style object if we need to. So let's say, for example, the user is interacting with a split panel, and that user is moving one of the resize handles. And there are, in this case, 3 child widgets. So that would be there's a left, there's a center, there's a right child widget. And so there's 2 splitter bars. And whenever the user is resizing one of those splitter bars, that the split panel is sending itself update messages because it needs to relay out all of its children based on the current position of the splitter bars. But if you're only moving the first splitter bar, then that third widget might not be changing position or size at all, especially if there's no maximum sizes set on those child widgets. So what that means is that the computed XY width and height, or left top width and height, for that third child widget is going to be identical on every single update request. On every single time we call update for that particular layout item. For that third layout item, these numbers are never going to change. If that's the case, there's absolutely no reason for us to make any writes to the style object and cause the browser to do any extra work, because it's definitely cheaper for us to compare numbers in JavaScript than it is for the browser to compare strings, or rather parse that string and check to see if that computed pixel value is the same as it was before, if the browsers are even doing that. So that's why we have these 2 clauses right here to check if we've changed the top, the left, the width, or the height. And in addition, if the width doesn't actually ever change, or I should say if the width or height does change, then we set this resize flag to true. And if that child has been resized from its previous size, this is where we create a new resize message for that child and go ahead and send it to it. So this layout item is actually doing quite a bit of logic for us that every single absolute position layout would have to otherwise do. Namely, detect if the child has been resized, make all those writes to the style objects, handle all of this size clamping logic, and then handling the horizontal and vertical alignment. So if you're using an absolute layout, or if you're writing your own custom layout, which is using absolute positioning, I would highly recommend you make use of this layout item class, because it's basically providing a lot of logic for you that you'd have to otherwise write yourself. And the final things are just the actual definitions of the attached properties. Again, following the same pattern we follow other places in Phosphor, the attached properties are actually private into the module, defined privately in the module. Then they're exposed through convenience functions. You've got the default horizontal alignment is center, default vertical alignment is top, and if the alignment, these vertical alignment properties or the horizontal alignment property for a widget is ever changed, then we've got a handler that says, okay, if the horizontal vertical alignment of a child widget has changed, and that child has a parent, and that child's parent widget has a layout, then we go ahead and call update, send an update request, or I should rather say post an update request to that parent widget, because that parent needs to relay out its children. because that child might need to be moved from center alignment to top alignment or bottom alignment or whatever the case may be. The parent's size itself hasn't changed, and the computed sizes of the parent haven't changed. So it doesn't need to be fit, but it does need to update itself and reposition all its children.